multiplied by the allocation cost multiplied by cost multiplied by allocation is 0. And availability will be some Delhi allocations. Hyderabad allocations. Chennai allocations. See? Similarly, demand. Demand. Pune, Kolkata, and Chennai. These are constraints. Repeat. Minimum total transportation cost will be the matrix product C3 to E5 cost matrix multiplied by allocation matrix I4 to K6 in my sheet. So according to your cell references, you have to give it. Availability will be the row sums. And demand will be column sums. This is LPP. This is what your LPP. Any question?
Sir, which method exactly are we following for this? Is this that, I think you had mentioned a method called
There is no method here. It's directly LPP.
So, sir, you had mentioned a method called something, if I'm not wrong, it was called northwest or something like that.
Just wait some time.
Okay, sure.
This is direct LPP. And now we can solve it by solver. The objective function will be my minimum total transportation cost. That has to be minimum. And the range will be all these allocation metrics. And the constraint will be availability and the demand. All are equal. So I can drag all the cell at a time. Equal to solve it. $7,800 multiplied by 100 rupees. Allocations are Delhi to Pune 150 Hero Honda, Delhi to Jaipur 50, Hyderabad to Jaipur 150, Chennai to Kolkata 100. This is my final solution. This
So
is my optimum allocation.
So can you
Sir,
please
could
do
you please show the solver again?
Yeah,
Sir?
yeah, I will show. You can see the screen, isn't it?
Yes, sir.
Yes, sir.
So initially my allocations are 0. And step 2, minimum total transportation cost, that is matrix product.
So can you maximize your screen?
It is maximum only. It is maximum.
So then maybe if you could just, zoom out a little bit so that we can see the entire screen once.
That is what I have selected, entire screen only. Is it visible now?
So we can only see the left part of your Excel sheet. So if we can see everything in one screen, so that will be very helpful. Like the steps, the final output, and the allocations.
Yeah,
All-
that is what I have made, arranged maximization.
But we can just see till O.
No, sir. Sir, your Google Meet screen is perfect. There is an option to zoom out in Excel itself, right? Towards the bottom right.
Okay.
So if you could please just zoom out so that we can see the entire Excel screen.
Now,
So zoom out, not shift.
now it's visible.
No, sir. Okay. Yeah. So your meeting screen is perfect. Only thing is you are zoomed into Excel. I think a bit too much. So you need to zoom out of Excel only, sir. The way you're sharing your screen is perfect.
So, sir, the part where it is written 100% on your screen on the right bottom side, if you can put it to 90 or 80%, that will be fine.
Okay. Wait a minute. All right, wait a minute. Okay, is it okay?
Yes, sir. Almost okay. Little bit more would be appreciated.
Now,
Yes, sir. Now we can see it.
so initially the matrix will be okay. So initially I have here the allocation matrix. Multiply it by cost matrix. So I get the objective function minimum total transportation cost, sum product of two matrices and the sum. Availability means Delhi, Hyderabad and Chennai total. So I have here Delhi total, Hyderabad total, Chennai total allocations. They are 200, 150, 100. Demand Pune, Kolkata and Jaipur 150, 100, 200. So this is LPP. This is LPP. Therefore, I can go directly to my solver. Objective function, minimum, range of the variable, that means allocation matrix, and constraint. And constraint. Solve it.
So can you just show and add the constraint again?
Yeah. My objective function will be minimum total transportation cost. That should be minimum. And my variable is nothing but allocations. And the constraints are equal. So at a time I can choose all. Okay. This is the algorithm. Solve it. Finished. So 7800 multiplied by 100 will be the total minimum transportation cost to meet the demand. 150 for Pune, 100 for Kolkata, 200 for Jaipur. So the shipment is Delhi is not sending to Kolkata. Hyderabad is not sending to Pune and Kolkata. Chennai is not sending to Pune and Jaipur. But demand is met, warehouse is empty. Okay. So this is the way we are going to work without any initial solution. This is the way we are going to work to get the optimum without any initial solution.
Sir, sorry to
But you
interrupt.
are,
So what do you mean when
but
you say minimum solution?
minimum total transportation
No, sir.
cost is minimum.
So you have just said no without having any initial solution. So what does that mean?
That means I have said here all zero initially.
Okay, sir. Sure.
I have said all the values are zero. But even I can have an initial solution. And that is to be verified as minimum. And such three methods are given in your syllabus. Northwest corner method, least cost entry method, and WAM. Northwest corner method, least cost entry method, and WAM. WAM means Vogel's approximation procedure. So that is what I am going to work now step by step. So the very first one will be northwest corner method. Allocations are obtained by northwest corner procedure. Okay, what does it mean? Initially it is zero. Start from left top cell. How much can be transported to Pune from Delhi?
$200 can be transported.
No,
And 150, sir.
150. 150 can be transported to Pune from Delhi. But do Pune want from Hyderabad and Chennai?
No, sir. There will not be any need for Pune to take anything from Hyderabad.
Okay. How many are remaining at Delhi now?
50, sir.
50.
Immediately transport to Kolkata. Is it possible to send to Jaipur from Delhi?
No, sir.
No. How many more you want for Kolkata?
50 more, sir.
That can be given from Hyderabad. And how many remaining at Hyderabad?
100.
100.
Can be given to Jaipur. How many more you want from Jaipur?
100.
From where you can send it?
Chennai.
Chennai.
Finished. What is the initial cost? What is the initial total cost you are getting?
8,700.
So when you have an initial solution, you don't know whether that initial solution is optimum. So verify it by solver. So again you have to go to solver, reset every time to avoid the error. Objective function will be initial value, should be minimum. Cells are already allocation matrix. And constraints are already we have left side. should be equal to right side and solve it. How much the answer you got?
7,800.
So what does it mean, this procedure therefore?
More effective.
What is the meaning of this procedure?
Sir, it means that the initial solution was not the most efficient one.
Correct. So if you want to verify the initial solution, again what do you have to do?
Sir, we didn't understand this sentence. If we want to verify,
If the initial solution is given, to verify whether it is optimum, what do you have to do?
sir, mathematically, we just have to prove one case that is better than that, and we'll say that is not the most effective solution.
So what is the tool here?
Solver.
Solver, sir.
Solver. So in the first case, I don't have any condition. Directly I went to solver. Not necessary. I can give one initial solution, or anybody can take an initial solution and check whether it is minimum. You have to do solver. So algorithm remain the same. Any question?
So, sir, here by this method, it's proving that the LPP was efficient, the answer that we obtained. Is this method just used to verify the LPP?
Yes.
And sir, what if the answer is different from the LPP?
No, you won't get it. You will get the answer in initial solution, but optimum never change. 8700 is the initial value. I don't know it is minimum or maximum or constant unless I verify it. So to verify whether the initial value which we got is optimum, you have to apply LPP through solver.
Sir, in real life, companies will not only consider cost, but they might also consider time as well.
Yes.
So if we were to factor
Profit
two
also.
things, yeah,
Profit also.
exactly. So if we were to
If the
factor multiple things,
transportation is by road, mileage.
yes, sir. So
If it is by rail, distance. If it is by sea, days. So transportation problem is not just for the cost. Anything.
yes, sir, exactly. That's my question. So if we were to, so then if we were to get an optimal mix between cost and time as well.
Correct. So several other factors also will be given, then accordingly you have to decide. Are you getting?
So that's my question. How will we factor multiple things?
Wait now. Wait some more day. Wait.
Okay.
I have already told you. In post office, how the postman get the region to go for distributing the materials? Early morning they come in the post office and sit in row. Classify all the materials according to their allotted area. How? How the area will be allotted to a postman? Tell me. Anybody? How a postman will be got allotted to distribute the material in a region? How it is decided? What the first criteria comes in the mind? Anyone?
Mode of transport.
Correct. Cycle. So he will get the allocations within a day, how many can be distributed, maximize it. If a postman has a scooter, he can get more regions to maximize the output. So they do manually, asking the postman. Here it is a strategic mathematical method, that's all. I can do that with postman also. Number of postmen, row. Number of regions, column, from existing post office. Write the mileage, distance, either in miles or kilometers. How many letters and work will be there for each? According to region, how to do? Okay, anyhow, first we have completing the algorithm first. Okay, so now northwest corner method gives an initial solution and by which you are getting the allocations which is minimum verified by solver. That is what I have shown to you. On the similar line, there is another method that is called least cost entry method. That is called least cost entry method. Look at the cost matrix. Which is the minimum cost? Which is the minimum cost?
15.
Which 15 you will choose?
Delhi to Pune.
Or
And
even I can go for the Chennai to Kolkata also.
yes,
Suppose I choose Pune. How many you can allocate?
150.
150. So these costs are nothing now. 30 and 20. Among the remaining cost, what is the minimum?
15 again.
So only to Kolkata from Chennai I can give 100. Now I have only 4. Only 2, 21 and 20. 22. Which is the least?
20.
20.
How many I can give?
Sir, 150.
150. And how much left?
50.
Finished. What is the cost I get?
So 7800.
Verify it by solver. Already we know 7800. So, because already I found. Even if I don't know, I have to go by solver and verify it. Here no need of verification because already we know it is correct. All the left constraints are equal to allocations. Perfect. So what is the difference in northwest corner method and LCEM? Least cost entry method says among the total cost matrix, choose always minimum. After every allocation, repeat the process among survival costs. That is what we have done. That is what the work we have done here.
So column wise, we have to see the minimum cost.
Not necessary. All together. Not column wise. All together. Anywhere the minimum can happen. We
So
will
like
see.
in ascending order. So like in ascending order, we have to go. Ascending order of cost.
Yes.
Okay, sir. Thank you, sir.
If the minimum is repeated, choose whichever you like. That is what it shows in least cost entry method. Let us see the last one now. Because the next example you are doing first, then I will be doing later. This is called WAM. The method is called Vogel's approximation method. Vogel's approximation method is a mathematically derived method, more reliable method. So in WAM, what it says is a different work. It says find the difference between minimum and the next minimum cost in each row. Say the first row, 15 and 20 is the minimum and next minimum. The difference is 5. The difference is 5. Next row, 20 and 25, the difference is 5. Third row, 20 and 15, the difference is 5. That is the first work. Repeat that for each column. 15 and 25. 15 and 20, again 5. 20 and 21 become 1. This is first step. Find the difference for each row and each column. How? By looking your cost. By looking your cost matrix. Choose the minimum. Which is the minimum? Which is the minimum? 1. In that direction, what is the minimum cost?
20.
In that cell, allocate. How much?
150 can be maximum allocated.
150 will be allocated. All the difference will change now. Hyderabad doesn't want the difference now. Why? It is empty. Delhi, again we want the difference, that is 5. Chennai, the difference is Pune, it is 5. Kolkata, it is 5. As well as Jaipur, it is
Is it
So
one?
1.
1. Which one? 21 and 22 difference, correct?
Yes, sir.
And Hyderabad, I don't want the difference. So in 1, the minimum 21, 22 become 21. So how many more you want?
So 50.
Again, the difference will change. After every allocation, the difference will change. So now Jaipur doesn't want difference. But Pune, Kolkata want 5. Hyderabad, we don't want. Chennai, again I want. Kolkata, I want the difference. 20 and 15, 5. And 15 and 25. Any 5 you can choose. Which one you will choose logically?
So we could choose Delhi because
Delhi.
since
Correct. So, Pune, I can give 150. No more difference. No more difference. Further? Further?
so no more difference.
1. No difference, but complete allocation will be given. How much is the answer you got?
So 17,500.
Verify by solver. So, my objective function will be minimum cost, allocation matrix, constraints are so much equal to what happened? Oh, made a mistake.
Some product formula, sir.
I know. 11, 16. Yeah. This is wrong. $9,400 is the initial solution, and give my solver. What is the answer we got?
$7,800.
So by all this procedure, what is the conclusion you can draw? Whether without solution, with northwest corner method, with least cost entry method, with WAM, I have here optimum answer same. That is the conclusion.
Excuse me, sir.
Yes.
Sir, can you please explain the WAM method again?
In WAM, difference, that is what you have to do. You have to find the difference between minimum and next minimum of the cost. So which was 5, 5, 5,
1.
1, 5 and 5 initially. So 1 is the minimum. In that direction, I have to allocate. So if you look at the cost, you will see the cost is minimum 20. Minimum is 20. So there I can give 150 units. So I don't want allocation to Hyderabad. Again find the difference. I am getting the same. Of which this is minimum. And 20 is the minimum. So 50 I can supply. Now I don't want the difference to Jaipur. These are the new difference. Choose any one.
So we could choose Delhi.
Yes, Delhi. 150 I can give it to Pune. So I don't want the difference of this. I don't want the difference of this. And only left is 100.
Which is Kolkata.
Yes. Is it okay?
Yes, sir.
Therefore, I say again, by all these procedures, we have seen what? Optimum value remains same. Optimum value remains same. Now let us see question sheet. You have to work first. This is a 3 by 4 matrix. Find initial basic feasible solution by northwest method, least cost entry method and WAM. Obtain the optimum cost. That means after finding the initial solutions, you have to use the solver and get the optimum is the meaning. Come on, start the work. I have given sharing of the question sheet. All of you have to start the work. Then I will show my final answer. Everybody should work.
Sir, can we tell the answer now?
Yes, just wait a few minutes. Is it 12075?
So the minimum transportation cost that I'm getting is 12200.
No. Check by solver.
So 12,200 is through the northwest corner method, sir.
Yeah, so northwest
But
corner method.
optimum.
Or the second question.
Second part.
Sir, it's coming as 12075.
Perfect. Perfect. Repeat for LCEM. You can save at the same time also. Northwest corner method, save it, copy and paste on somewhere and then do by LCM and save it. That will help you in exam.
So what's the answer with LCEM?
Yes, how much you got?
It's the same as
12,275.
Yes.
So from third VAM method, I'm getting 12075.
Yes. Go in the middle. Ali Asagar,
Yes, sir.
is it okay?
Sir, I'm stuck with the VAM method.
Okay. Rahul Ghosh,
Yes, sir.
are you working?
Yes, sir.
Ah. Amit Ingle,
Sir, trying, sir.
ah. Vineet Sharma, Nikhil Agarwal,
Yes, sir.
are you working on the problems?
Yes, sir.
Ah. Don't sit idle, everybody should work. Sanika Thakur,
Yes, sir.
you are working on examples?
Yes, sir.
Ah. Anchal Jain,
Yes, sir. The working.
ah. After another 10 minutes, I will give. Then I will work.
Sir, what was the answer for the VAM method? I'm getting 15,075.
It's 12075.
That's the final.
Yes, sir, it's 12075. 12075.
Yeah. Okay, let me start working now. This is what the initial setup. 3 by 4. 3 origin and 4 destination. This is my allocation matrix. So first I am doing by northwest corner method. A to D, 200, 1050. The down it will be 175. And left it will be 225. and 50.
Sir, 225 it would be 125.
Yes,
125, sir.
125, 125. Then here 150 and 250. So answer will be 12,200. Check by solver. Remember, every time you have to reset all. Cell references will change. May make you problem in examination. So the optimum value will be 12,075. This is what I got by northwest corner method. In exam also you can prepare a table like this. Now let us go to least cost entry method. Among the cost, 10 is the minimum. I will prefer the last 10, C to G. Allocation is made. Now minimum is 11. So I can give 200. Now the minimum is 13.
13.
Right. I will go for this. 150 I can give. Now 13 is the minimum. 225 you want. You have only 50.
You can only give 50.
And here it will be nothing. Already 150. You want 175. And remaining 125 here. Finish. Again I have here 12,200. By solver, same answer, 12,075. So let us go by one. Difference. Both the ways. Row as well as column. Row difference 13 and 11 2. 10 and 14 4. 13 and 10 3. And here 11 and 16 5. Next 13 and 18 5. Next 14 and 13 1. And the next 0. 10 and 10 difference is 0. So 0 is the minimum. In that direction 10. Say for example I will choose this 250. All my difference will change. I don't want the difference for G. The first still remains same. 11 and 13 2. Here also I want the difference 16 and 14 difference is 2. Next, the difference is 13 and 21 become 8. Here, 11 and 16, 5. 13 and 18, 5. 14 and 13, 1. This is the minimum. That direction minimum cost will be 13. That is this cell. I can give 275. Now F also doesn't want any difference. But D, 11 and 13, 2. 16 and 18, 2. 21 and 24, 3. Here, 11 and 16, 5. 13 and 18, 5. Minimum is 2. Whichever 2 you want, you can take. Say I take this. In that direction, minimum is 11. So, I can supply 200. No way, 50 has to be the next. And the remaining will be 50 here. And 275. So, here we have 125. 400 minus 275 become 125. Finished. 12, 8, 25.
Sir, could you please repeat the VAM method? I didn't understand the first allocation, the 250. Why did you allocate the 250 from B and not from A?
Yeah. Answer is again 12075. I repeat again, bam. First difference between row, minimum and next minimum, 2, 4, and 3. Here, 5, 5, 1, and 0. So, this direction minimum is 10. I have selected this 10. Any 10 you can choose. So 250. So this difference I don't want now. Check again. 2, 16 and 18 now. 2, 21, 13 and 21 become 8. 5, 5, 1. This is the minimum. In this direction, minimum is 13. So the allocation will be 275. No difference. Again, 2, 18 and 16, 2, 21 and 24, 3, 5, 5. So now the difference is 2 times. Choose any one. I selected A. 11 is minimum. Give 200. Obviously 50 has to be here. Another 50 left, that has to be here. And the remaining 125 has to be here. Is that clear? Is it clear? So, In the question sheet, the problem also we have done 3 by 4. In both the examples today, we have proved optimum remain the same. Initial value can be any. Initial value can be any. So this is the first situation of solving TP. The transportation problem will be solved for a balanced TP. Initially, we have taken 3 by 3 matrix and proved. And right now, we have taken 3 by 4 matrix and proved. In both the cases, it is a balanced transportation problem. In both the cases, it is a balanced transportation problem. No matter what is the initial solution, optimum never change.
Sir, I have a question. Sir, why is VAM not the most optimum solution even though it considers the entire opportunity cost involved in transportation?
That depends on the cost, na.
Sir, but we are allocating as per the opportunity cost, no? So it should be the most optimum, na?
Yes.
Sir, but in this,
But
it
what
is the most
happens,
expensive.
minimum cost will be repeated. You see.
So, but then these two, in this scenario, we have calculated northwest cost and lowest cost. They are cheaper than VAM.
Yes.
They are not very scientific methods to say compared to VAM, but why are they more cheaper than VAM?
Yes. This is the initial solution now. Forget about northwest corner LCM and VAM. You give a solution and do. Still, you have to go for solver.
Sir, and how does solver exactly solve? Because I am not able to understand the mechanics behind it. I can understand the coding, but what works behind it?
Correct. Behind the solver is called UV method. After initial solution, we have to apply the procedure called optimization technique. That optimization technique is called UV method. That is the basic one for the software of solver. In the class we do on the board by hand. In the class, when we do the problem like this, we don't want solver. But in online class, it is not possible. So every method is initial, but solver is the final. That is UV procedure, basic cell, non-basic cell, etc., many things comes. Okay. So,
if it's possible, can you teach the UV method if you get the time? Because we need to. Sir, if it's possible to you, then.
It is possible. Why not?
Sir.
Let us complete the syllabus.
Okay, sir. Thank you, sir.
Anyhow, I have to take sensitivity analysis. So when I take sensitivity analysis, I will go for UV also, UV method. But for that, you require rigorous mathematics. Keep in the mind. Okay. So today we have done only one work. How to solve balanced transportation problem for minimizing the transportation cost. Instead of cost of shipment is given. If the profit is given, then what is the change? Tell
Sir,
me.
we'll have to
So we
maximize.
would maximize profit.
Correct. Given problem is a transportation problem, balanced transportation problem. But instead of cost of shipment, profit per shipment is given. Same algorithm. Objective function should be maximum. Okay, next. If the distance mileage is given to you, or if the distance kilometers are given, then what to do?
Minimize, sir.
Yes. Remember, therefore, what is actually asked in the problem and what is actually given in the problem. Accordingly, you have to verify the objective function. Number 2. The given transportation problem is unbalanced. That means either total availability is more than demand, or the total demand is more than total availability. In such a situation, we have to convert that unbalanced TP into balanced and then solve it. If the total availability is more than total demand, then in some warehouse, some units will be left. They are not empty. So remaining product can be manufactured later. If total demand is more than total availability, some distributor may not get all units. In the next shipment, consider him first. We have to do such problem also. Because next class will be all miscellaneous work of TP. Next class will be for miscellaneous type of questions in TP. Next, suppose one doesn't want to send to one distributor. Then how to do the question? Constraints are conditional. Constraints are conditional. Then what to do?
Sir, what's the question again?
Suppose from one production center, the sales manager disliked to send the product to one distributor because he might not have paid the last amount. Then what to do about allocation for maximum minimum?
Sir, you can
Even
set a
if-
constraint. We can set a constraint for that distributor to be 0.
Yes, that we have to see. Whether it is 0, whether it is positive, whether it is negative, because for him, one distributor is left, one distributor is disconnected. Suppose if 4 distributors are there and 3 centers, one center doesn't want to send for one distributor. So that distributor has that center has only 3 distributors. Others are having 4. So it is a different type of example compared to balanced or unbalanced TP. So all such miscellaneous work, that is what we are going to start next class. Okay, further. When we do transportation problem, whether it is balanced or unbalanced transportation problem, the same algorithm will be doing for assignment problem. So once you know all the cases of transportation problem, assignment problem also simple. That is a different work. Whether a given question is a transportation or assignment problem, solver algorithm remain the same. Why TP and AP? Even in LPP, everywhere there is an objective function, there are variables, there are constraints. Okay. Now for your examination point of view, you have to be well aware about your cell references. Today, when I have done according to my cell references, same way, when you are typing the data or data will be given on particular area of the sheet, you have to be aware about the cell references. If the cell reference goes wrong somewhere, your answer need not be same even if you do by solver. Therefore, every one of you have to be well familiar about a location. A small introduction I will give today for a miscellaneous work. Look on the screen. Four distribution centers, and three origins. Two 50, 200 and 300. 750 units are available. Now, 220, 230, 280, 270, 1000 units is the demand. So the demand is more than 750. Which means 250 units are required. Additional 250 units are required. I introduced that as dummy. That means it is not existing. So, because it is not existing, there is no cost of shipment. Hence, it is balanced. So, what does it mean? What does it mean?
It's a dummy issued to call.
Dummy is introduced to convert the TP into balanced, that's all. And because of 0, it will never include in my computation. It will never include in my computation. So in this example, total requirement more than total available introduce dummy center. Similarly, if total availability more than total demand, then what is to be introduced?
Sir, one more distribution center, one more
Correct.
consumer.
Dummy consumer. Therefore, in both the cases, you want a dummy center or dummy distributor. You want a dummy center or a dummy customer. And that makes you the TP balanced. Once you make the TP balanced, then you know how to solve it. Because we have seen today algorithm for balanced transportation problem. We have seen today the algorithm of balanced transportation problem. But if it is unbalanced, the first you make balanced. And to make the TP balanced, either introduce a dummy production center or dummy customer. 0 will be the shipment cost, whether cost of shipment, profit, mileage, whatever it may be. For dummy, it is always 0. It is always 0. We are going to work, but let me give introduction. That's all. Okay. Now, from O3 to D3, he doesn't want to sell the product. He doesn't want to send the product to D3. So if I keep this 30 and work on algorithm, possibly allocation will come. Can anyone tell me what modification necessary?
Sir,
To
can we add a
minimize-
constraint? Can we add a constraint to make cell D4 0?
No. 0 I cannot make.
But he does not want to sell now. O3
Yeah.
does not want to send to D3. So
Yeah.
if we add a constraint that cell D4 must be 0, then automatically O3 will not send to D3.
That is the mistake. When I want the minimum minimum total transportation cost, then allocation will come at 0. Correct, na?
Sir, I didn't get that part.
If my objective will be minimum total transportation cost, and if I make 0 here, I will get the minimum total transportation cost. Am I right?
So given
Because
the
0 is also a minimum number.
yes, sir.
So instead of 0, what is to be done? Take the Birbal example. I have a line. How to make it shorter? Don't touch the line. How to make a drawn line become shorter?
By drawing a bigger line.
So instead of 30, I may give 300. No allocation will come there because objective is minimization.
Okay, sir. Got it.
Ulta, if this is a profit problem and maximize the profit, then what shall I do here?
So minimize this.
Yes, I will give a negative 300 or any other number. Any you can give. Allocation will never come. Such is the work that we are going to start on the next class. Conclusion, my algorithms are same. My algorithms are same. But given problem can be of any type. Accordingly, I have to modify my matrix, cost matrix. After modifying the cost matrix, you can speak about all the steps which we have shown today. Chitwan Garga, Chitwan Garga, Sherry Chabra,
Yes, sir.
do you follow the today's
Yes,
work?
sir. Yes, sir.
Gaurav Kadam,
Yes, sir.
when you can say TP unbalanced?
Hello?
Yes, when you can say a transportation problem is unbalanced. Mohit Mishra, When can you say a transportation problem is unbalanced? Porgallidade. Muyastajit porg. Anybody?
Sir, can I try?
Yeah.
Sir, when demand is not equal to supply, in the problem we saw of motorcycle
Total demand is not equal to total
supply.
supply.
So, like in the problem, the first problem that we saw Pune, Delhi, Hyderabad motorcycle one, where demand was matched as 1000, but for example, if demand was only 900 and the supply was 1000, then we had to introduce a dummy row or column with 100 demand and we'll allocate as per it, and whatever demand is allocated to dummy, that is the unsatisfied, sorry, that is the excess demand, and it will be allocated to the highest cost because we are at the lowest cost.
Yeah. Good. Pitanjal Datta,
Yes, sir.
what do you follow today? Can you summarize?
Yes, sir. So first we saw that how to solve a linear programming using the basic solver. So we arranged the problem in two matrices, and then we basically used the sum product and we framed it as an LPP, and then we used solver to solve it. So that was the first thing that we did. Then what we did is we used the northwest corner method and VAM method and the least square method as well. So these are the three methods that we learned how to solve step by step. And lastly, we saw that if it's an unbalanced problem, then how to make it balanced. So we added dummy column, rather a dummy row to equate the total demand and total supply so that it becomes a balanced problem.
Okay. Rachit Tyagi.
Yes, sir.
What is the difference in the earlier classes and today's class?
Sir, in this class we introduced the non-balanced transportation problem. In the previous class we did LPP and the basic transportation problem.
Is it the solver algorithm remain same?
Sir, most probably basically it's same, but the cell reference and the other yes, sir, the other thing related to that is
Okay.
likely the same.
Okay. Savi Agarwal.
Yes.
Yes, sir.
Do you follow today's work?
Yes, sir.
Okay. Shubham Kumar.
Yes, sir.
You follow systematically how to work on TP?
Yes, sir. But I have a doubt, sir.
Yes. Ask.
Sir, like when we apply the northwest method and get the results, then after that, if we want to check with the simplex by the solver, so
Yes.
which cells are taken as a destination? Like after the cell that we in the northwest methods are applied, or the raw cell for the cell destination.
Northwest corner you can take. To take northwest corner method ka solution cell, no problem.
Sir, it didn't give any relevant data like raw.
It will give the correct optimum.
Okay, sir.
No matter whether northwest corner method, least cost entry method or VAM, when you go by solver, you will get the correct optimum. Vibhor Khanna.
Yes, sir.
How do you find today's class?
Yes, sir. It was good.
So you have to revise all before we meet next class.
Sure, sir.
Okay. So I am assuming that all of you got correct understanding of TP first step, that is solving a balanced TP. And based on this, we are going to work on different situations. By Saturday, you will get a new question sheet on which we have to start our further work of TP. And once the TP is get clear, then your correct assignment problem will be solved. Nikhil Agrawal.
Yes, sir.
How was the class test?
And good, sir.
Okay. Bhavya Dank.